In this segment, we're going to continue working with fractions and adding fractions. We're going to be adding proper fractions, and in this time we're going to be talking about working with proper fractions with different denominators. And I'll be using the pattern or fraction blocks, Cuisenaire rods, and the array model to do it pictorially that I showed in the previous segment. So our question we're going to start off with is 1/2 plus 1/3, and we'll use this block, this double hexagon, as our 1. And if we're using our double hexagon as 1, then a single hexagon would be 1/2. There it is there. And our 1/3 would be the black chevron shape. And so there's our question, 1/2 plus 1/3 using the pattern blocks. Remembering that when we add things, they have to be the same kinds of things, and clearly we don't have the same kinds of things. We have a yellow hexagon and a black chevron. We can't add them together because we don't have two of the same kinds of things, so we have to figure out what we're going to do. Before we start working with them, though, I just want to point out that lots of students, if we're just teaching it symbolically, will take the 1/2 plus the 1/3, and they're going to say 1 plus 1 is 2, and 2 plus 3 is 5, so my answer is 2/5, and it makes perfect sense when all you're looking at is the symbols. However, if we're taking a look at the shapes, it's quite obvious that the answer can't be 1/2, but even looking at the symbols, we can talk about using our reference that we talked about before when we were talking about comparing. We can take a look at our possible answer here of 2/5 and find out, is that even reasonable? So we start off with 1/2, and we're adding to it something else, and I get an answer of 2/5 apparently. Well, halfway of fifths would be 2.5/5, so we're almost at half in our answer here. But in my question, I'm already at half, and I'm adding a bigger piece to that. So getting an answer of 2/5 really doesn't sound like a reasonable answer. And so we have to make sure that we talk about, is my answer reasonable? And think it through before we actually worry about the techniques. We've got the idea of comparing fractions. We've already talked about a referent of a half. This question has a half, and we're adding something to it, and we're asking them to give an answer, or they've come up with an answer that's less than a half. That makes no sense, and we want to make sure that we discuss these kinds of things with students so that they can use their knowledge of a referent to help them figure out if their answer is reasonable or not. Because looking at just the symbols, 2/5 makes sense. 1 plus 1 is 2, and 2 plus 3 is 5. But when thinking about it, it doesn't really make sense. We want to help the students figure out, is my answer reasonable or not? So trying to figure it out the proper way, we want to find a common denominator. And why do we need a common denominator? Well, if we're looking for a shape that we can count up the same numbers of things, if I wanted to use this, I can put one of those there. I can turn an upside down version for it to be here. I could cover up that piece, but then I'd have this piece hanging out. So this shape is not going to work. I cannot make my combined yellow-black shape out of this, so that can't be my common denominator. And these are 1/4 of my double pink, and so therefore 1/4 or 1/4 can't be my common denominator. My black chevron works here, but it doesn't work here because it's going to be leaving a yellow piece, so that one's not going to work, so 1/3 isn't going to work. Trying this one looks promising. I can get a series of these to fill in, and this one is going to turn sideways to cover that. So it would look something like this. And these two yellows here can be split up amongst those, and so we can get that. So we can use this blue shape to cover it up. So therefore we need 1, 2, 3, 4, 5 of these blue shapes. And what are the blue shapes? Well, it takes 1, 2, 3, 4, 5, 6 blue shapes to cover a whole. So the blue shapes are called sixths. So my common denominator is going to be sixths. And now that I have something in common, I can add up all the yellow and black pieces. I get 1, 2, 3, 4, 5. So my answer is 5/6. And so there's my statement there. So let's take a moment to show what the symbolic work might look like to connect that manipulative to the symbolic that we were expecting. So here's the work we might want to see. 1/2 being changed to 3/6 by multiplying by my magic 1 of 3 over 3. 1/3 changed to 2/6 by multiplying by my magic 1. And then I can take my 3/6 plus 2/6 equals 5/6. But let's talk about this work here. How does the student know that the work has something to do with the pictures? And I want to make those explicit because lots of students don't see the connection. So we talked about what shape is going to work for filling in both the yellow and the black, and we figured out that it's this shape here. And so we're going to take a look at how many does it take to fill up one hole. So if we take 1, 2, and 3, we see that it takes 3 of these thirds, or 3 of these, to fill up a piece. So therefore we could call them 6, but we could also call them 3/3 makes up a whole. And so because it takes 3 to fill up this 1/2 piece, I'm going to be using my magic 1 of 3 over 3, and that gives me my 3/6. When I want to fill up my black piece, I'm going to take one of those and one of these, and it takes 2 of these pieces to fill up my back piece. So that's why I'm using my 2 over 2 magic 1 to change my 1/3 into 2/6. So I want to make that clear to the students why I'm choosing this magic 1 for this one and why I'm choosing a different magic 1 for this one. It takes 3 to make this shape and it takes 2 to make this shape, and that's why I'm using those versions of magic 1. Then I can go ahead and make my 3/6 and my 2/6 and get my total of 5/6. So I'm going to move the work over to the left-hand side here and show how the same question can be done using Cuisenaire rods. Using Cuisenaire rods, if my red rectangle here is a whole, then my white is 1/2, and if my green is a whole, then my white is 1/3, because it takes 3 whites to make a green. So this is my 1/2 plus 1/3 question. But I can't add them together because my colors aren't the same here on the bottom. I'm not collecting like terms. I don't have the same common denominator is another way of looking at it. So my question is, what color can I make that's going to allow me to be made out of reds and be made out of this light green color? And if we've done some work with multiples with Cuisenaire rods, we can take our red and we take 2 reds, and 2 reds aren't equal to a green, so that's not going to work. So, but that's too big, so I need to add another green. So if I compare that to 2 greens, 2 greens aren't the same as 2 reds. But if I add another red to this, I'm going to get something that's going to be equivalent. So those two together should work, and those are both equivalent to this. So we see that we have our 1/2. If we take 3 of these, I can make a green, and if I take 2 of these 1/3, I can make a dark green. So therefore, if I triple this, I can take 3 whites out of my reds. So here's the diagram that might show how all the pieces fit together and how they're related to one another. So I can see that my total is now 1, 2, 3, 4, 5, 6 pieces. So this dark green piece we could call 6th, which is where my 6th comes from here on my common denominator. I can see that it takes 3 of these reds to make that. So if I take one of these and I have to multiply it by 3 times to make my new common denominator or my new dark green, that's where my magic 1 of 3 over 3 comes from. So I've got 3 of those right there. So there's 1, 2, 3. And if I take a look at this one, I notice that it takes 2 of these greens to make a dark green. So therefore I have to multiply this one by 2, and that's where my magic 1 of 2 over 2 comes from. If I multiply it by 2, I get 2 of these. And so when I add them all together, I get 1, 2, 3, 4, 5. And there's where I get my 5. And I have 5. And these things are called 6ths because it takes 6 of them to make my dark green. So I can use my Cuisenaire rods as well to produce an addition of fractions. A student might notice that the half and the third now becomes the third because it takes 3 of them, and this now becomes the half. So for this half I now have 2. To make a third it takes 3. So to make this third I take 1, 2, 3, and together that gives me a total of 5. That's another way that a student might look at it, and notice that the half now becomes a third, and the third now becomes the half. And we notice that reciprocal kind of idea, or it's not reciprocal, but it is related to one another. And so we can see that that's another way of using Cuisenaire rods to work on it. It's a little bit more complicated that way. And the third way is using the pictures that we talked about before, and I'll show you how that works now. So here I have my box. It's length 1 by length 1, so it's a square. And I've taken my 1 and cut it into 2 pieces, just so that I have 1 cut into 2 pieces, 1/2. I've taken my 1 and cut it into 3 pieces. There's my 1/3, so I have 1/2 plus 1/3. So here I've created my 1/2 piece. I've shaded in 1/2 of my box, and I can either use that half or this half. It doesn't make any difference, but I'm just going to leave them over on the left hand side. So there's my 1/2. Now I'm going to draw my 1/3, except I'm going to do that in a horizontal manner. And here's my 1/3 piece going horizontally. There's 1/3, another 1/3, and another 1/3. I'm just going to put it up at the top. And remember, since we're adding, we want to add our pieces together, our single colored pieces. So I'm going to go ahead and show that. I have one segment here, so there's 1. I have another segment there, there's 2. And I have another segment there, there's 3. And as we talked about before, I have a segment up here in the top corner that's colored twice. Once with the yellow, and again once with the blue. So I can count this one twice, so I can count this one twice. So how many colored pieces do I have? 1, 2, 3, 4, 5. And how many segments do I have altogether? 1, 2, 3, 4, 5, 6 sections. So therefore I get my 5 pieces out of my 6 total, and I get my answer of 5/6. Adding up my single colors, and this corner up here is a double, so we count it twice. So there's my 1/2, there's my 1/3. 1/2 plus 1/3 is 5/6. And I've shown this in multiple ways, and you can choose whichever way makes most sense to the students.